All right, today's lesson is on solving systems of equations by elimination. So far, we've done it by graphing and by substitution. Last one is elimination. So today, our focus is going to be on the last method, which I just mentioned is elimination. Just like substitution, there's a lot of steps. There's 5 steps, but it's very, very similar once you get about halfway through. Okay, so the first couple steps are going to be a little bit different, and then afterwards, you're going to be like, oh, I've done this before. So step one is going to be rewrite the equation so that the variables, constants, and equal sign line up correctly with each other. Step two is going to be to multiply one or both of the equations by the constants so that at least one variable has matching opposites. And I'll show you what that looks like in a little bit. Step three is going to be to add the equations together and solve for the remaining variable. This is going to be the first half of your answer. From here, it should be very similar to what you've done before. You're going to use the first answer and substitute it back into either equation to get your second half of your answer. Then you're going to write your answers in order pair. So let's just get into it and show you what I mean. Use the substitution. That's not substitution. It should say elimination method. Sorry about that. Let me cross this out. No. This is the elimination method. To solve the system. So x plus y equals 5, and then 2x minus y equals 4. The first thing I want you to notice is that these are opposites of each other. Well, first of all, let's notice this. You see the x and the 2x? These are lined up, but they're not opposites of each other. Here, I got a y and a negative y. These are opposites of each other, and that's very, very important. I have the equal sign with the equal sign, and then the constant with the constant. That is to say, the number by itself, okay? So step one, rewrite the equation so the variables, constants, and equal sign line up. They are lined up. Step two, multiply one or both of the equations of the constant by at least one so that at least one of the variables has matching opposites. I don't need to multiply that in this case because I already have matching opposites here. And the whole purpose of this is when you add those matching opposites, they need to cancel with each other. So right now, let's just go ahead and trust me. I can go ahead and add these up right now because one or at least one of my variables is going to cancel. So let me go ahead and add these up. When I do this, x plus 2x, that's going to give me 3x. Y plus negative y, these cancel each other out. The equal sign is going to drop, and I have 5 plus 4, which is 9. All right, that's a great start. From here, we are going to go ahead and do step three. We added the equations together, and I need to solve for the remaining variable. In this case, my remaining variable is x. I'm going to divide both sides by 3. I get x equals 3. This is the first part of my answer. X equals 3. Now that I have x equals 3, I'm going to go ahead and substitute it into either equation that I want. And it's the original equation, guys. So I'm either going to substitute it into this one, or I'm going to substitute it into this one. I think the top one looks a little bit easier, so let me go ahead and substitute it there. I'm going to write, instead of x, I get to replace that x with the number 3. This is going to say 3 plus y equals 5, because I already know what x is. And then we're going to solve for y. So subtract 3 on each side. These cancel, and I get y equals 2. This is the second part of my answer. And then the last step says, hey, go ahead and write your answer as an ordered pair or as a coordinate. So we're going to go ahead and write it as 3, 2 is my solution. Sometimes they're going to be very fast like this. Sometimes they will not be. And it's just going to be on you to recognize whether we need to do anything with it. So let's take a look at letter B. Letter B, again, step one is we need to make sure that they are matching up in the right spots. So I got x's with x's, y's with y's, the equal sign, and then my constant with the constant. So step one is done. Step two, I need to multiply either one or both of the equations so that I have opposites right on top of each other. Right now, I do not. I have 3x with 3x, and I got a negative y with a 2y. If I were to add it right now, nothing would cancel. So I need to change to something. Just because this 3x matches up with this 3x, I'm going to go ahead and multiply this bottom one by negative. No, let me go ahead and multiply the top one by negative 1. Everything's going to get multiplied by negative 1 on the top. So I'm going to go times negative 1, times negative 1, times negative 1. When I do that, what I end up with is negative 3x plus y is equal to 13. The one on the bottom, I'm going to go ahead and keep the same. 3x plus 2y equals negative 1. Why did I do that? Well, because now I have matching opposites on the top and on the bottom. Now when I add them up, I get one of my variables to cancel. And that's exactly what I'm looking for. So I'm going to go ahead and add these up. These are going to cancel. I got y plus 2y, which is 3y, is equal to 13 plus negative 1, which is 12. Now that I'm done with step number 2 and I'm halfway through step number 3, I'm going to solve for the remaining variable. In this case, my remaining variable is y. So I'm going to solve for y. I'm going to divide both sides by 3. And I get y is equal to 4. That is the first half of my solution. I'm going to take that y equals 4. I can plug it in whichever one I want. I'm going to go ahead and plug it into this one right here. So what I'm going to write is 3x minus, and in this case, my answer is 4, is equal to negative 13. Because x, there's only an x, I'm going to go ahead and get rid of what's being done to the x. Right now, they are subtracting a 4, so I'm going to go ahead and add 4 to get rid of that. These are going to cancel. I get 3x is equal to negative 9. Divide both sides by 3. X equals negative 3. This is the second part to my solution. Remember, you're going to write your answer as a coordinate. So you're going to write it as x comma y, which in this case is going to be negative 3 comma 4. And we are done with the second one. So hopefully that made sense to you. Like, it's really not that bad. You just need to kind of figure out, all right, what do I need to multiply this by? If you need, sometimes you don't need to multiply it by, right, by something, but if you do need to multiply it by something, like what am I going to multiply it by so that they cancel when I add, right? All right, so first thing we're going to check is make sure that these are lined up. I got x's, y's with y's, my equal sign, and constants. So these are lined up perfectly. If they are not lined up perfectly, you're going to rearrange them so that they are lined up perfectly. And you know how to do that, okay? All right, does anything cancel when they add them up? Nope, not right now. So now I got to figure out, okay, is it possible for me to multiply one of these by something so that way they cancel up and down, right? I don't care about this one. I care about your variables. You want to cancel one of your variables. I think if I multiply this one by 4, then this becomes negative 8, and that's going to cancel out with this positive 8. So I'm going to multiply the bottom one by 4 all the way through. Everything gets multiplied by 4 on the bottom. And what that's going to do is that's going to keep this the top one the same, because I'm not changing the top. 3x plus 8y equals 7. But on the bottom, that is going to change the 2x to an 8x. It's going to change the negative 2y into a negative 8y. It's going to change the negative 10 into a negative 40. Now that I have these, I'm going to go ahead and add these up. 3x plus 8x is 11x. The 8y and the negative 8y, those are going to cancel, and I'm left with a negative 33. Now I can go ahead and solve for the remaining variable. I can solve for x. I'm going to divide both sides by 11, and I get x is equal to negative 3. This is the first part of my solution, is x equals negative 3. I get to choose where I'm going to stick that negative 3 into my x into. I'm going to go ahead and choose to pick it on the top just because there's some negatives on the bottom. I don't like doing that. So we're going to go ahead and substitute, and I get 3 times negative 3 plus 8y is equal to 7. That means negative 9 plus 8y is equal to 7. Now that I have the variable y by itself, I'm going to undo what's being done to it. And right now we're adding that negative 9. How do I get rid of a negative 9? Is I add 9 to both sides. These are going to cancel. I'm left with 8y is equal to positive 16. Divide both sides by 8. And I get y is equal to 2. Lastly, we write our answer always, always, always as a coordinate or as an ordered pair, which means I need to write this as x comma y, which means I need to write this as negative 3 comma 2. And we are done with that one. Okay, we got 2 more examples and then a couple word problems, and then we'll be done with this. They will get a little bit more confusing just because, math tends to do that sometimes. So let's see. Lined up, lined up, lined up, lined up. Great, right? Everything matches. I'm going to check to see if there's something that I can easily multiply the top by to kind of cancel with the bottom, and I don't see anything. And what about the other way? Can I multiply something on the bottom by so that way it cancels with the top? I don't see anything either. So then the question becomes, what do we do when you can't easily change one of them? When you change two of them? So almost like common denominators, right? If I take a look at these two, notice that this one's positive and this one's negative, and that I can change the 3 and the 2. Like if I were to use 3 and 2 as least common multiple of 3 and 2, it's 6. I can change the 3 into a 6 by multiplying it by 2. And I can change the 2 into a 6 by multiplying it by 3. So we're actually going to end up changing both. Again, what am I going to multiply this one by? I'm going to multiply it by 2 because I'm trying to get 6 to match up with the negative 6. So let me go ahead and multiply everything on the top by 2. What I end up with is 4x plus 6y equals 0. And let me also change the bottom one, but in order to change the bottom one, I want to multiply everything by 3. What I end up with is 15x minus 6y is equal to negative, oh my goodness, what is that? 3857. Why did I do that? Well, because look what happens now. I have a positive 6y and a negative 6y, and these are going to cancel out. By the way, that wasn't the only option. I could have actually multiplied this one by 5 to get 10, and multiplied this one by negative 2 to get negative 10. So there's more than one ways you could do this problem. It's just whatever number you see I think is a little bit easier, you're going to go with that one, okay? So now that I have them matching up and it looks like something's going to cancel when I add them, I'm going to go ahead and add the two equations up together. 4x plus 15x, that's going to give me 19x. 6y and minus 6y, those are going to cancel out. 0 plus negative 57, that's a negative 57. We're going to divide both sides by 19. I just happen to know that that's 3. So I'm going to say x is equal to negative 3. That is the first half of my answer. I'm going to take that x equal to negative 3. I get to plug it in anywhere I want as long as I plug it in for an x. I'm going to go ahead and substitute it into this one because it looks like those are easier numbers. So let me go ahead and start that off. I'm going to replace the x with a negative 3. This is going to say 2 times negative 3 plus 3y is equal to 0. That means negative 6 plus 3y is equal to 0. I'm going to undo what's being done to the 3y, which is adding negative 6. I can get rid of that negative 6 by adding a positive 6 on both sides. These are going to cancel. I'm left with 3y equals 6. Right now, the y is being multiplied by 3, so we undo it by doing the opposite. We're going to divide by 3. Y is equal to 2. I got both parts of my answers now. Remember, we're going to write it as a coordinate, x comma y, so I'm going to write this as negative 3 comma 2. And that is my answer. All right, this is the last easy one, I would say. Again, first thing we do is we check that they're lined up, and the equal sign matches to perfect. It looks like I can change that x to match up with this 3x. If I want it to be the opposite, though, I'm going to have to multiply it by negative 3. So let me go ahead and multiply the entire bottom by negative 3. Everything on the bottom gets multiplied by negative 3. The top is not going to change. I'm going to leave it as 3x plus 3y equals 14. The bottom is going to change. It's going to change it to negative 3x minus 3y is equal to negative 12. Guys, it's really important that you really line them up, and it just makes a huge difference. All right, let's see what happens. These are going to cancel. Perfect. These are going to cancel too. That equal sign needs to drop. Let's not lose that. 14 minus 12, that's going to give me a 2. Do you notice how there's nothing, like these canceled over here on the left side? You cannot leave this blank. Like, I know there's nothing there, but we have a number for nothing, right? And the number for nothing is 0. So don't lose that 0. What the heck? We have a statement that says 0 is equal to 2. Don't freak out. You've done this before. You've seen this. When you have a number, a false statement like 0 is equal to 2, 0 is not equal to 2. It's false. And when stuff like that happens, that means there's not going to be any solutions. So 0 equals 2 means no solution. Remember what this means. What this means is on this graph, if you were to graph this and you were to graph this, you'd get two lines. And chances are, nope, not chances are, I'm telling you right now, they're not going to touch anywhere. So those lines are going to have to be parallel. If you were to graph both those equations, they have to be parallel to each other because they're not crossing each other up. Okay. All right, so that takes care of the first 5 problems. Let's go ahead and see a couple more word problems. I know these are a little kind of difficult. We are going to have a lesson dedicated just to word problems, but that'll be down the road. I just kind of want to expose you to them so you can kind of get an idea of what they look like. All right, here we go. It says, example, you buy 4 donuts and 1 cookie for $12. I buy 3 donuts and 2 cookies for $9. What is the price of the cookies and the price of the donuts? So in this case, what I don't know is the price of the cookies and the price of the donuts. So we're going to go ahead and start by defining our variables. I'm going to say let C be the price of the cookies. Let D be the price of the donuts. Now I know some of you guys are going to say, wait a minute, we did a problem like this before and we didn't define it this way. We defined it as how many cookies and how many donuts. Well, I know how many cookies I bought and I know how many donuts I bought, right? So that's not a mystery. In this case, the mystery is the price. So that's why we're changing it, okay? So you've really got to be kind of careful with these type of problems. Okay, what do I know? Well, I know when I bought them, it cost $9. So when I bought 3 donuts plus 2 cookies, it cost me $9. This was the price for me. And the other one, let's see, this is going to be, you bought 4 donuts and 1 cookie and it cost $12. So let's write that. 4 donuts plus 1 cookie, your price was $12. This is price for you. So those are my 2 formulas that I have. Now that I have them, I'm just going to go ahead and set them up. Notice that they're already lined up really nice. So I'm going to go ahead and start using elimination method. In order for this to work, though, I'm going to need to multiply this bond on the bottom by -1. Nope, just kidding, by -2. I'm going to multiply it by -2. That way my C's will cancel out. So I'm going to multiply by -2, by -2, by -2. All right, what are my new formulas? My new formula in the top, this is going to be, it's still going to say 3 donuts plus 2 cookies equals $9. When I multiply the bottom by -2, though, it's going to say -8 donuts plus -2 cookies. I know that's a really weird statement, but that's not what I'm worried about. I'm worried about the math behind it right now. Is equal to -$24. We're going to go ahead and add these up. When I add them up, 3D plus -8D, that's going to be -5D. These are going to cancel. It's going to equal to -15. Divide both sides by -5. And I get D equals 3. Be careful, because I know it says donuts equals 3. That does not mean that you bought 3 donuts. Remember, what did D represent? D represented the price of the donuts. So when D equals 3, that means the donuts cost $3. Okay. I'm not done because they also wanted to know the price of the cookies. So now that I know the first half of my answer, I'm going to take this and I'm going to substitute it into either one that I want. I'll plug it into that first one. And so let me replace that. That's going to say 3 times parentheses 3 plus 2C equals 9, because I know that D equals 3. I was able to replace it. 9 plus 2C is equal to 9. Subtract 9 on each side. These are going to cancel. I get 2C is equal to 0. Divide both sides by 2. I get C equals 0. So that's the second part of my answer, right? What does that mean? That means the cookies cost $0. So in this case, the cookies are free. Now on word problems especially, you probably should write a complete sentence. So my answer, what was the price of the cookies and the price of the donuts? The cookies, I'll write the donuts cost $3 and the cookies were free. All right, and we are down to our last one. Tom bought 3 mystery novels and 2 science fiction books for $35. Sarah bought 2 mystery novels and 4 science fiction books for $40. How much was the price of each book? So it's very similar to the problem that we just did. Let me go ahead and define our variables. The first thing I'm going to say is let M, because I don't know how much the price of each book is, right? So I'm going to go ahead and define my variables that way. Let M represent the price of a mystery book let S, S represent the price of a science fiction book. Be careful when you do your 5s in a math problem, because, S's in a math problem, because S's tend to look like 5s. So just be really, really careful. Make sure that your S and your 5 looks way different. All right. So now I know what my M and my variables stand for. What do I know? I know that Tom bought 3 mystery novels and 2 science fiction books for $35. So I'm going to go ahead and write that. 3 mystery books, that would be 3 M's, plus 2 science fiction books, that would be 2 S's, and the total price was $35. Be careful again. Look at my S and look at my 5. They look very similar, so you just really got to be careful when you use the letter S, okay? In fact, I kind of don't like it. So let me try to make that S a little bit more curvy so that I know it's not a 5. So 3M plus 2S is equal to 35. This is the price for Tom. And for Sarah, she bought 2 mystery novels and 4 science fiction books for $40. So I already forgot what I said. 2 mystery books plus 4 science fiction books for $40. This is for Sarah. Is there any number that I can multiply by so that they cancel? Yeah, it looks like I can multiply the top one by -2. So let me go ahead and do that. I'm going to multiply this top one by -2. -2. -2. When I do that, what I end up with is -6M minus 4S is equal to -70. And then on the bottom, I get 2M plus 4S. I like that because now they're going to cancel when I add them, is equal to 40. Let me go ahead and add those up. These are going to cancel. I'm left with -4M is equal to -30. We're going to divide both sides by -4. In this case, I would probably use a calculator. M is equal to 7.5. Does that mean she bought 7.5 mystery books? Nope, because remember that M represented the price of a mystery book. So that would be $7.5. But nobody speaks like that, so that would be $7.50. Okay, that's the first part. Now I have the first half of my answer. I'm going to take that 7.5 for M. I'm going to replace it anywhere I want. As long as I replace it for the M, I'll replace it on the first one. What is that going to turn into? That's going to turn into 2 times 7.5 plus 4S is equal to 40. 2 times 7.5, that's 15, plus 4S is equal to 40. Subtract 15 from each side, I get 4S is equal to 25. Divide both sides by 4, and again, that's probably going to be calculator work. We're going to say S is equal to, what is that, 6.25. And again, that doesn't mean that she bought 6.25 books. That means that she paid $6.25 for each science fiction book. So let's go ahead and write our sentence. we're going to say the mystery books, forgot how to spell mystery, let's try that again. The mystery books cost $7.50, while the science fiction books cost $6.25. Okay, that takes care of the notes for today. As always, if you have any questions, please feel free to ask.